So this is a question on Voronoi diagrams and space, and it's showing these different points, which are measures in kilometres, and they're the boundary regions from different wardens at the stations. And I'm told the coordinates of the various ones, so P is 10.6, Q is 13.7, A, B, C, and D are also given above here. So I have all the information that I would need. I just need to keep referring back to it because it's not actually labelled on the diagram. So for the first part, I'm showing that the new station should be built at P. So we know that if we're ever adding in a point, it should always go into one of the vertexes of the Voronoi. So it would either go into P or Q, since that's where my Voronoi diagram meet. Okay, so it should always go in those vertexes. I need to decide whether it's P or Q. So to do that, I need to choose one of my coordinates or one of my positions. And I'm basically finding which is the closest distance and which is the furthest away. And I want to place it at the furthest away because that's going to be the most beneficial. So it would probably be easiest to either pick B or D to do this because I can use the same point to measure the distance to both of them and find which is further away. I could do the same here with B, or I could do A with P and C with Q, for example. But we know that this distance is going to be the same, and we know that this distance is going to be the same, and I just need to find the two. So the distance formula is in the formula book, and it's the y2 minus y1 squared plus the x2 minus x1 squared. So it's basically Pythagoras that you're doing. So you could take B. B is a nice coordinate, if you like. It's 14 and 2, whereas D isn't quite as nice to work with up here. Okay, so we might want to take B. So the distance for B and P, so B to P, is 10 minus 14, and then squared. And then I have 6 minus 2, and again squared. And then all of that is going to be square rooted. And then I'm going to do the same again, but this time it's B with Q. So B to Q, and that's 13 minus 14 squared plus and 7 minus 2 squared. So these are both formulas just found in the formula book for the distance between 2 points. So all I'm doing here is taking my, for B and P, it's 10 minus 14, 6 minus 2. And then I'm doing the same for B and Q, so 13 minus 14 and 7 minus 2. And when I put that through, I find that the first one is root 32, or as a decimal, which you might prefer, it's 5.66. And then the second one is 5.10. And therefore, the one that is furthest away is this first one, B and P. So it would make more sense to put it here because it's going to be more beneficial if it's further away. And then for part B, I'm showing the equation that's perpendicular to the bisector of PC. So P to C, if I was to join those two up, if I want the perpendicular bisector, then it goes through the midpoint. Now, because that's a nice horizontal line, and you can see here it's only one mark, so you know it's going to be relatively straightforward. And it's a horizontal line, so we can find the midpoint very simply. So it's 1, 2, 3, 4, 1, 2, 3, 4. So we can see there it's that middle point, which is going to be 14, 6. So 14, 6 is the midpoint. And we know that the gradient is going to be vertical because the original is horizontal. So this line here comes through, and this is the line x equals, because it's a vertical line, and it's x equals 14. So my equation is just x equals 14. So that one mark shows me that it's a simple one to do, and I don't need to do much more. So now that I've done that, I need to, if I imagine I've added in this coordinate P, I'm now going to continue to draw my Voronoi diagram. So for this last part, we're then joining them together to form the Voronoi diagram. So we know from part BI that the line between P and C is this vertical line here. We've already got the one from P to B drawn in, and we've already got the one from P to A drawn in. And this is this one here. So the only one I've still got left is this one. And we literally just join it together from those 2 points. So it's just a line going between the two. Let me draw that a little bit better. So it looks something like that. And that is your then your finished Voronoi diagram. So it's 2 marks. It's only 2 marks. That's how you know it's not too much work. And it's just drawing 1 mark for each of those lines.